let's go to event 5. Event 5 is a circle with the tangent, secant, and the angles. So first, let's go and talk about how to figure out the angles. So when you have a circle, the key is to see where the vertex is. Okay, so if the vertex is on the outside of the circle, then so let's call this x. So the angle x would be, if the vertex on the outside, it's going to be half of the difference. So x will equal to a minus b over 2. Okay? If the vertex on the outside, you subtract and you take the half. If the vertex is on the inside, so if the vertex is on the inside of the circle, then you add. So x will equal to a plus b over 2. Okay? Now, if the vertex is on a circle, then it doesn't matter. Okay? If the vertex is on a circle, it doesn't matter you add or subtract because b equal to 0. So that's x and this is a, right? So in this case, it doesn't matter because b is 0. So it doesn't matter if you minus 0 or plus 0. So in this case, x equal to a over 2, right? Okay, now another situation, if it's the center, so that if this is the center, then in this case, this would be a and a, right? Because they're the same, right? And so in this case, x will equal to a plus a over 2. So x will equal to a. So if the vertex is the center, x will equal to a. Okay? If it's on the circle, it will be a over 2. Okay? If it's outside, you subtract, divide by 2. If it's on the inside, you add, divide by 2. So they're able to figure out all the angles. Okay. Now also one more situation. If you have the equal arc, then you will have an equal angle. Okay. So in this case, see, angle x and angle y are equal because they have the same arc. So in this case, x equal to y. Okay. So that's another situation. Now, when it comes to the length, it doesn't matter if it's a tangent or secant. The key is the product of the length or the distance from the circle to the point would be equal. So in other words, so if you let's do the easy one first. Let's say if you have this kind of situation. Okay, so this is A, B, C, D. Okay, so here's the point of intersection, right? So from point to circle, that's A, right? So from point to circle, point to the circle, will equal to the point to the circle times point to the circle, right? So you can point to the circle times point to the circle of the same length will equal to point to the circle, point to the circle. So it doesn't matter where the point is. So if you look at different situations, so let's say if you have a tangent and you have the secant. Tangent means it touches the circle at one point. Secant means it touches 2 points. Okay? So again, from here, so let's call this A, and this would be, I'm going to call this C, and I'm going to call this D. So again, so over here it's going to be A times A, right? Because from point to circle, because what happens is that it merges, this is like a double root, right? Double. So point to circle equal to C from point to the circle. Now you have to be careful. A lot of people make a mistake of doing this times this. Okay, so that would be incorrect. It would be from point to the circle times from point to the circle, this entire length. Okay, so again, point to circle times point to circle equal to point to the circle, point to the circle. If you remember that, then everything is all very easy. Okay, and even with this, if you have two secants, So here's your A. Let's say if this is B, okay, and this is C, this is D. So you have to be careful now, okay? So in this case, it's going to be point to the circle, and then point to the circle will be A plus B, right? And then equal to C, right? Point to the circle times point to the circle, in this case will be C plus D. Okay, so again, point to circle equal times point to circle equal to point to circle, point to circle. Now, if you have a tangent, it's a double, right? So point to circle, point to circle. So once you know those rules, and you can use that to solve, almost any problems.
Ashton to report to the school office, please.
Okay, one of the type of the problem that you see often is the one from the 87, 88, the C problem. Okay. This type of problem shows up quite often. So what you want to do is you have a circle. So it says a circle can be drawn through point X, Y, and Z. So when you're doing this kind of problem, right, you want to draw the circle first. It would be a little bit easier. Okay, so that's your X, Y, Z, and this is 6, this is 8, this is 12. Okay. Now, when you're doing this, right, first what you want to do is go and draw 2 chords, okay? And then you want to draw a center, and then what you want to do after that is you want to draw 2 diameters that are parallel to that. So draw 2 diameters. So next, what you want to do is you want to use Pythagorean theorem, okay? So, first you have to remember the rule we did, right? So point to circle, so here's your point. So 8 times 12, right? 8 times 12 equal to 6 times, I'm going to call this A, okay? And so, again, don't multiply out. What you want to do, divide by 6. So A will equal to 16. So this over here would be 16, okay? So the next thing is, you need to figure out the half of length. So if you notice that this is 16, this is 6, so this is 22, okay? So this part would be 11. So this would be 11 right over here. Okay, so this is 11 right over here. And this is 6, so this would be 5 right over here. Okay, so you can slide it over. So this is 5. Okay, now don't slide it over. Okay, so this is 5, and then you go and do the same thing this way. So this is 8. This is 8. This is 12. So total is 20. Okay, so half would be 10. So this would be 10 right over here, and this would be 8. So this would be 2 right over here. So after this, you can go and use your Pythagorean theorem. Okay, so you can figure out your radius over here. So now you're going to have 5, 10, and a radius. Okay, so go and factor out of 5. So you get 1, 2, and this is square root of 5. So R equal to 5 square root of 5. Okay, so that's a quick way to do it. Okay. So that's going to do a few more. So again, this type of problem you see it quite often. Okay. So you can see it from 96, 97 is another one. So if you go to 96, 97, so 96, 97 C problem. So again, this is event 5. So this one, it says AC has a length of 10, and point B is 3 from AC. So this is 3. from the AC. Okay, and 5 from the A. So you got to kind of, so you can take off your name tag and use as a ruler. So this is 5. So 3, 4, 5, right? So this would be a 4. So this would be a 6, right? Okay, and this is total is 10, right? Okay, so you can write all that. So again, you're looking for the radius of the circle. Same problem, right? So you need to draw 2 chords, and you need to draw 2 diameters. Okay, so you need to draw 2 diameters. So draw 2 diameters. Okay. So again, you go and so you need to figure out this length over here. So and you can use a ratio, right? This is twice as much as that, so this would be twice as that, right? Or you can write it out. So 3 times the length, I'm going to call it L. So this times this will equal to 4 times 6, right? So you can point to a circle, that's this over here. So this times this equal to this times that, right? So divide by 3, divide by 3. So L equal to 8. So this is going to be equal to 8. Okay, so now we're going to do we're going to start to figure out the length, right? So this is 4, this is 6, so total is 10. So this would be 5 and 5. Okay, so this right over here is 5. So now we have to do this part over here. So this is 8, and this is 3, so the total is 11. Okay, so 11, so this is 5.5, this would be 5.5, so this would be 2.5. Okay, and this would be 5.5. So again, this is 3 and 8, so total is 11. So 11, and this would be half and half, right? So 11, so you get 5.5, 5.5. So, and this is 5.5, but this is 3, so 2.5. So I'm going to put in a fraction like this. So again, so now we're looking for the R right over here. Okay? So now you have this situation. You have 5 over 2 and the 5 and the R, right? So what I'm going to do is I'm going to factor out the 5. So it'd be 1/2, 1, and I'm going to call this X. And I'm going to factor out the 1/2, so it becomes 1, 2, and Y. Okay, so you can do all that stuff. Okay, or you can factor out 5 over 2. So again, this use your Pythagorean theorem. The reason I do that is much easier to figure out your Pythagorean theorem. So 1, 2, so a squared plus b squared equals c squared. So y equal to square root of 5. So x will equal to square root of 5 over 2, right? You just go backward. And r will equal to 5 square root of 5 over 2. Okay, so that way it's much easier to do the math. Okay, and that's it. Okay. Okay, now another type of problem you see a lot is when you have 2 circles that tangent to each other. Okay, as soon as you see 2 circles to each other, you need to go ahead and draw a trapezoid in. So let's go to 90, 91. And the B problem. Okay, so you have 2 circles. So whenever you have 2 circles next to each other, tangent like that, what you need to do right away is you need to go and draw a trapezoid. So what you need to do, you need to go and draw the tangents. Okay, so draw this. Draw the radius. Okay, so form a trapezoid, and then you need to go and draw a rectangle. So basically, you need to draw this rectangle. So draw the trapezoid first, and from here go across like that. And after that, it's fairly easy. Okay, so a circle with radius of 5 is externally tangent to a circle radius of 20. So this radius is 20, and this is 5. Okay, so again, this is 20, and this is 5. So you can see, you can slide this over. So this would be 5. This would be 15. Okay, and also this is 5. And this is 20, so So this over here is 25. So now you're looking for this right over here. So you can use Pythagorean theorem, right? So from here, right? See this over here. This is also the x. So basically, what you have is you have 15x and 25. Okay. So if you factor out the 5, you get 3, 5, y, right? So from here you can see this is the 3, 4, 5 triangle. So this will equal to 20, and that's it. Okay. So very quick. Okay. Done.